Okay, we are back live. Hello. Cheers. Evening stream. 2 hours, 2 hours 40, no, 2 hours 20 minutes probably. Probably finish around 9. We're gonna see what we can get done on this refactor. That's the idea. I'm gonna try to just get this thing, like... We'll see how much progress I can make. But yeah, I really want to have a full prototype of this thing by the end of the day tomorrow. So, hopefully I can get a good chunk of this done. Otherwise, I'm just gonna have to, like, really block everything else out and do this all day tomorrow. And I'd like to have some time for other stuff. So, let's get started on this. Where'd the music go? There we are. Alright. Okay, we were working on this ridiculous string bullshit, right? I've always said, like, the one thing that annoys me in C is string processing. It's just such an obnoxious operation to have to do. Let me see if I can just, like... Hang on, I have to actually look a couple things up for this, probably. Pass 2D. They pass 2D char array. Yeah. What's the sig? Array of 10. Because it's fixed, right? That's not bad. Like this. Okay. I see. How do you, in general, avoid nesting for loops from writing code? Why would you need to avoid nested for loops? Who told you that? Whoops. Okay, I didn't do this label right, but we can fix that. In Python, a lot. So that's the problem. Yeah, that's not faster. It, like, or not that much faster. That's the problem. If you're trying to do an operation that requires nested looping, and it's not easy to write as an array ops, you're using the wrong language. I can write whatever the hell loops I want in C, and it's fast. See, that's the problem with Python, right? It gives you new stupid problems to solve instead of just like getting good at using the small set of tools that are like fast and actually work. It gives you new problems to solve because it introduces a bunch of new tools at the price of making everything else slow as hell. Stupid Python. The hell? Uh, ticks. I will admit string processing in C kind of sucks. Oh. Yeah, fun errors, right? Okay, this one works. Really? Why is this still doing this? I don't understand why this is still like this. What? Oh, dummy. Yeah. Alright. That's just me being tired. There we go. Okay, so let's see what we ended up with here. I don't think we ended up with particularly less code. I think we kind of just ended up with more bullshit. Right? So even after I went and did all this... Well, I guess, hang on. If we put these two functions back into the draw ticks... That's so obnoxious, though. Come back to it. Ooh. I think I like squashing all the data for this. Yeah, I think we just do this. I could probably do like like a blend additive or something on this. I can probably like do everything composited and get this nice. Yeah, this is kind of crap as well, isn't it? Kind of a lot of stuff that's crap in here. Finally, I can run my environment in PufferLib. 600 FPS, an immense joy. There you go. How should I use PufferLib? On discovering phase? Well, we can get even faster than 600K if you have a decent GPU, I'm sure. So... Alright, hang on. Alright, so you're gonna need to learn to read this plot. So this plot says you're only spending 3%, 4% of the time on the environment. So, like, trying to make the environment faster doesn't help you much. Copy here means that it's actually spending a decent chunk of the time copying data back and forth. This is kind of a puffer thing, but if you have obs that are over a few hundred bytes, then you can probably reduce it to make it faster. Other than that, this is the amount of time spent in the forward pass of the neural net during data collection. This is miscellaneous time. This is forward pass during training, learning time, copying data around, and miscellaneous. So you can kind of see where your bottlenecks are. If you have a fast env, you're going to want to have pretty large batch and mini batch sizes. Check our defaults. We're usually using 32,000, somewhere between 8 and 32,000 mini batch sizes, and we have 4,000 plus parallel environments. So it's a really large scale compared to what you'd be used to. But the thing is, it's so fast that who cares about steps, right? You care about solving your problem fast. So yeah, you're going to want to do that for perf, and then just run puffer sweeps. Learn how to use puffer sweeps because protein is our sweep algorithm that's really, really powerful. And other than that, yeah, enjoy, right? Don't be afraid to read the code. The code's really short. PufferL is pretty much the entire training thing. It's one file. It's like a 1,200 line file, but only the top 500 lines are the actual algorithm. The rest is logging and stuff. And that's Puffer. And Puffer's getting even faster and even better every update. That's what I'm here working on every day. The thing that you've been watching me work on stream, right? Constellation. This is going to be the largest scale visualization toolkit for RL. Look at this. Wanbi, super slow, can't handle a bunch of data points. Boom. We have all our data points, right? Everything you possibly want to look at. Many M's, many metrics, right? We're going to have everything right in here. 470 super. Gonna convert. Oh, it's 600K even in Python? So yeah, look at that little percentage number next to your env, and if that's significant, then you can make it faster and see. That's so funny, you get 600K in Python. Oh, that's funny. If you haven't, I don't know if you've done low-level dev before, but if you haven't, absolutely learn some low-level dev. Low-level dev rocks. It honestly, I was starting to get kind of down on programming. I'm being real. Because I'd written Python for 10 years, and just, I didn't feel like I could build everything I wanted. Everything kind of felt slow and clunky. And low-level dev has just reignited that, and I just love building stuff again. And also, this shader looks so cool. This shader is so cool. It's probably not the best for actually looking at data, and I'm going to have to add a toggle for, boring mode. But come on, you can't tell me this does not look so cool. No mechanics. Jess is doing chess. Python is second. Then what have you been doing? Screw Python. What are you doing? You literally know, Kung Fu. Go beat him up. I gotta go pay XOR dev because the effect is based off of the actual why it looks so good is based off of the attenuation by XOR dev. I'm gonna go drop him $100 or whatever for this because I used one of his his public shaders. He doesn't even have a buy button on his shaders, but I'll go drop him something. Anybody tried Doom? Okay, so mechanics. If you want to do Doom, there is a binding, and I found there's a hidden setting in Doom that's not in the binding that everybody uses that lets you render it at a really low resolution. They have like a potato resolution in there, and I think I got it to like I got it to some pretty reasonably high FPS. You can definitely get over 100,000 FPS on Doom if you want to do it. Welcome, FBR. All right, how are we going to handle all this log transform crap? I'm kind of conflicted here, guys, because like you can kind of see what happens, right, when I do like when I make plotting functions and I try to make them general. Like this is a general draw ticks, okay, because it just takes like labels. But then you're tied to this plot arg struct, which I guess I can like keep tweaking. The thing that's kind of gross to me is I think I'm going to end up with more code if I refactor it this way. Like, I'm thinking, okay, maybe plot 3 shouldn't have all this crap associated with it, right? And we'll just make it like... It's like basically every single time you want to make the thing general or whatever, I'd end up having to copy all the data again. Custom torch encoder, did for ocean amps. It depends on your environment, XF. So the way to think about it is you want to match the encoder to your environment. So if your environment has 2D data, you probably need comms, right? If your data is just flat and it's like continuous, you can just use the flat encoder. If you have discrete data, then you need to one-hot it. So it's not so much like, well, what policy is better? It's just you want to fit an encoder to your data. It will nerd snipe you. I do have to refactor it. It just depends what direction, like what direction I go. If I just like leave this as is and I walk away from this project, this is going to be unusable in 4 days. Like I definitely have to clean it up. It's just a question of what direction do I go in. Bicycle kinematics, I see. Well, but it depends on just like what your data is, right? If you have like, if you go look at your data and it looks like Pong or if it looks like Drone or whatever, where it's just like state data that's not associated with any dimension, it's continuous, it doesn't need to be discrete encoded, then you just use your flat embed and you're good. I think I want to freaking do this. I mean, you can't possibly look at this and tell me this is an okay signature for a plot function, right? But at the same time, like, having plotting library abstractions actually feels wrong. Now that I've been building this stuff in C, right? Like, you end up having to do so much more data transformation and bullshit when you have an API that gives you, like, a plot function. We're gonna think about this a little bit now, because this is gonna drive me nuts otherwise. I was thinking, like, oh, I could make, like, a little plot library in C. But the thing is, like, having a plot function, you're already kind of screwed, aren't you? I guess it depends. Hmm. Well, because it's like, okay, the plot function, it supports logging any axis, right? There's the camera, which you need to transform the data from 3D to 2D because of the shader, because we're not using just like 3D draw function. There's filtering, right? There's like a filter on it. There's a color map on it. Which, like, it's better to have a color map like this than it is to have an array of color structs, technically, isn't it? But this is completely gross. And also having, like, a plot function that takes hyper is also gross. Readable and humane to use. Yeah, but then think about it, right? Then, like, instead of just, like, filling the value, normalized value that I want to convert to color, now I had to have to write an extra loop in order to call the plot function, right? I have to write an extra loop to convert the color instead of a value. And then if you pass a C map instead of passing colors, then you lose the ability to do custom colors. And then at some point, it's like, what the hell are you even doing? Because, like, if you're going to make it so general, the function gets to be like 10 lines. So it's like, why do you even have a function where you're going to have to redo all these buffers when the function doesn't even do anything? Fuck, I hate abstraction. Okay, like, this one is correct, right? The only one I actually am sure about is the plot GL function. Funny enough. Why am I sure about that one? That's a good question. Let's go interrogate that. Oh yeah, I'm sure about that one because it's a mess of OpenGL nonsense. And you don't ever want to have to frickin' touch this. You just give this thing the shader and you give it vertices, right? And then it goes and draws it for you. That's a good primitive to have, right? That's like the only thing in here that actually feels good. %2% env and evaluate, is that fine? Yes. Yes, fiber. 2% env time is reasonable. You don't get 0 unless you're doing double buffering, which I guess is sometimes default, but Yeah, that's fine. Well, XF8, it kind of depends on how nice this is, right? If I get a really nice plotting library about this, then from this, then I'm going to use it on a ton of stuff. If I get some garbage that's like completely single purpose, or if I get not garbage, but if I get something that's like totally single purpose with no, like nothing I can remotely reuse. But in my mind, like reuse, like making something reusable shouldn't mean, in order to reuse this, you have to change the way that you would write it if you weren't going to use this function, right? Go for what? Well, I mean, go for like, yeah, think about it and like do stuff. Sure, that's fine. I'm fine spending time on this, but the fuck do I do? I mean, I guess. Ah. Well, hang on. I guess what if I do? What if I combine filtering? I could combine, if I take an array and I could combine filter, log, map to screen. I think there are going to be some primitives out of this. Fuck it, I'm going to have fun with this. We're going to actually do some stuff on this tonight. It'll be good. Here, we'll do, let me use a restroom and we'll do impromptu pull-up set. And then, we continue. Welcome, Major. I'll be right back. We'll show off the pull-up. Okay. Pretty proud of that. Not bad, right? Can't just throw it all in structs. 1.6K? Let's see. 1.5. Load 3 bounds. Nice pull-up form. That's with a 45. 6 reps with 45 pounds of weight. Solid enough. Well, major we do. It's just the question is, I'm getting kind of stuck on. So I like this plot GL function, right? It just takes points and puts them to the shader. But like, look at this plot function. It's disgusting. I'm trying to think if I like... Maybe if I try to make it look more like... Well, then you'd also have to do for log as well, fiber. Super obnoxious. It's like so obnoxious. John Carmack, yeah. That would be awesome. That would be awesome. I've honestly been thinking about just like reading some of his code just to see what the hell I'm missing. He wouldn't be staring at this like, how do I refactor this, right? Like, am I just stupid or is this non-obvious though, right? Like, what the fuck do you actually do with this? Do you need an axis? Is that what the thing is? Like, that feels bad too, doesn't it? You have your damn data. Having a plot function, maybe. Why am I trying to refactor this code? I want to get this thing polished up. And I'm hoping that I end up with like some semi-general or like some semi-reusable plotting interface out of the project at the same time, right? You know, I could see this becoming constellation.c and plot.h. Upper plot.h or something. Like, it's not entirely uncommon for us to want to make plots in our viz. Is the correct interface to this, like, some really small signature, like X, Y, Z or whatever, and then, like, a big plot arg struct? Is that it? That's almost like object-oriented programming shit, though, isn't it? Like, making big structs where everything is big struct is very... I mean, that's object-oriented programming with extra steps. That feels like a cop-out as well, right? Like, where do you draw the line? Hmm. Yeah, I think that you don't want to put arrays into... I think when you start putting, like, variable length arrays and shit into the struct for plot args, that's when you're fucking up, right? I think having, like, the axis... Wait, if you put, like, an array of 2, can I pass null? Yeah, so I want an init. You can't, yeah, because it doesn't have a pointer. Yeah. Can't use -1. Can't do dot length. I can just check them both against 0, right? That actually works. So let's like work on this. If I were to do if I just do float x bounds 2 like this, oh actually, hang on, I can do it even like this. I just have to check them against 0. Yeah, I just have to check them against 0. And then log is also goes in here, right? So that leaves color. Yeah, the Python, I've got too much Python variable typing, like variable type sig in my brain here. I think that would fix it though. The only other thing is the color. I guess if we just pass, it's annoying, but we pass CMap as a void star. That's how you would do it, right? That's still not amazing. Font color, background color. Okay, so the fonts thing is because there's a weirdness with Raylib. There's a weird thing with Raylib that makes the fonts awkward. Font color, background color. Oh, you just mean put them all. I don't really like doing them all in the same line like that. Okay, wait, here's another question, right? Here's another question. Do we... Hmm. You know, shit. I don't like the idea of having to collate a shit ton of render textures either. It could pass a bounds as a rectangle. I wouldn't have to do any deferred rendering that way. That could work. And what do we do about color? Int erase like this. Size T. Wait, what? Equivalently decay to star. Size, okay, so they pass. Well, I know size T major, but I have not used, I've kind of leaned towards using the minimum number of types possible. So anything that is not included as anything that is not included by default that I have to import for an extra type. Something totally different, fiber. Okay, let me think about this. So, well, you definitely don't pass filter, right? I could pass a point instead of passing a instead of passing XYZ, I could pass like a vertex, no, points or whatever. Does that fix it? Minimalism. What's the Linux kernel use? It defines its own version. That's funny. I mean, I think this is like a minor stupid detail. Oh, that's funny. Hmm. I didn't realize that. Oh, it decays. Okay, that's insane. Yeah, that's insane. You have to have this static size prim. Okay. I see. Just some rough edges. So where does this leave us? Let's go look at our usage. Because we have a filter here. Yeah, Major, apparently. I didn't actually know that. But this, like, again, kind of just leads me to, like, if you just use the simplest possible subset, you don't hit these problems, right? If I just say, fuck it, the param is an int star, everything is, like, everything that's not a static array is a pointer. Let me see how we do this in, like, in actual use. Let's see what my plotting function looks like. To tell us something. So let me see. We try to get these hyper values. And then we get a color map. Probably by looping over it. The best code is the cleanest, in some sense by definition. And if the two disagree, then your sense of aesthetics is off. What would I like this to look like? Num_ems under env and train. Yeah, so that's a little rough edge. My apologies for that, XF8. So, under env, that's not a required parameter. That's just something we do by convention with ocean environments. Because ocean environments, our first-party pufferenv format is a vector format. So each instance of a pufferenv has many envs internally, and that is what that version is. The vec parameter is the number of workers, so it's the number of replicas. So if you set vec to 4 and the env1 to 1024, then you're going to get 4096 total ems across 4 cores. They shouldn't be called the same thing, but it's actually kind of difficult to come up with something accurate to call them that would be different. Without just naming one of them N, which isn't helpful. You know, I think my ideal interface here would just be constructing a big array of points, right? Because you're going to calc the color map anyways, right? Why don't I fully like that? I guess the reason in my mind that I don't fully like that is, like, what if I just want to pass float x, y, z? But then what would you do for color? That would only give you one color, right? Yet again, this is like Rayson being a genius, right? Rayson handles this by having a simple version. He has like a few different versions. He has like EX and Pro and stuff for his methods. I'm really starting to appreciate even more and more just what a good dev that guy is. Number of workers passed my hardware core count. It threw an error. So XF8, probably the default vec_num_envs in sweeps is more cores than you have. Yeah. So XF, it's the defaults are set pretty generous. Do you not have Oh, I guess do I not even have it in here? I actually fixed it in my dev branch, if you see this. It's probably set to like 16 or something. Just change it in the config default to match your number of cores. Never have come up with that scheme. But like, look, literally, this is yet another instance where Rayson just gives us the answer to how to do this. Because this guy's just like, he's such a great programmer in so many ways. Like, look, draw a line V, draw a line EX. So in a language where you do not have the ability to overload one function to have multiple signatures, he just says screw it and he gives you like some short suffix and then he just puts them right next to each other, one line each in a cheat sheet. So it's like super obvious that you can do it any of these ways, right? And then like it's like, oh, but you should only have like one input. Like there should only be one way to do things. It's like, no, you're going to have your data in different formats depending on what you're doing. So I'm just going to give you multiple interfaces and you can use whichever one like is going to fit the cleanest with how the rest of your code happens to be structured. But it's not like three completely different ways. It's just three slight different formats on stuff, some of which give you like extras that you might need sometimes. And he never has big structs in here for anything. I think this is the answer, right? Is that you just like I'm honestly curious. Is there like I kind of want to go read some of Carmack's code for comparison. Well, it's not going to just be all Carmack, right? It's Python. It's also kind of dumb to be looking at like literal 30-year-old code, right? There's so much to learn from this. XF8. So in config/default, there's a setting there for the sweep that has vecnum ems. Just set the max of that to your course. And probably don't do 14. Do like, you can just set it to 8. Wait, what? What is .qc? Oh, QuakeC. Wait, they have their own... Wait, what? Okay, the new line curly braces are sending me. I have vanilla ice cream. uh... Interesting. Did they make a C scripting language? Some of the, like... Okay, some of, like, the really, like... The low-level dev just, like, coding practices just drive me nuts. The new line curly braces just drive me insane. I think Rayson even does that shit, though, doesn't he? Uh... Here's the big file. Yeah, this drives me nuts. Why do people do this? At least he doesn't do the 8-space indents. I mean, this is just all a major diversion, right? But... One extra line. Okay, but like if you count the number of extra lines, like look, so 1, 2, 3, 4, 5, 6, 7. There goes like a good chunk of my screen space, right? Nope, we don't have a format file. Okay, so that's going to be go insane with Clang format. I have always hated auto formatters. I care about stuff like, should I write my stuff this way or that way? I don't care about having it automatically enforced. Because generally, like, it would also help if most of the auto formatters didn't suck. I actually don't know in C, but like in first of all, like in Black, for instance, Black in Python, I hate that shit so much because everyone's like, "Oh, look, now you can read the code because it's auto formatted," but it's the worst auto format ever. It'll put like multiple returns on different lines and shit. It's insane. I think that the correct like rich interface is to have a point, right? Full of errors. You end up doing some really stupid shit in the process of trying to become a better programmer, okay? Look, did I write this? I think I released this article somewhere on X, didn't I? I forget if I just put it on my website or if I actually put it on X. Okay, no, I didn't do it here. I think I just put it on... Did I put it on this? I wrote some article somewhere that was like... I was basically trying to write C-style code in Python, and because like I was trying to write less bloated stuff, and I didn't realize that the language itself, like I didn't realize that the language itself basically penalizes you for trying to do that. So I wrote some really stupid looking code for a while, even put some of it in Puffer in the process of like trying to figure shit out. Okay, does Raylib have a point? Like, does it have like point in it? Actually, here, let's just do... I think it's glyph, right? Glyph or marker. Just do point. This is easy. C code like in Python. I spent a very long time on that. Yeah, we had this for a while. So I tried to make, I had this namespace thing, which I tried to do. I did this in order to try to make something that was vaguely like a struct. It was like a hybrid between a struct and a dict. And there were a few other weird things as well. Where do I have it in here? I was not writing classes for a while. I was doing some like weird shit where I was basically like writing structs within a init method. So like, I don't even know what the hell it was. But I was basically doing shit the way you would do it in C, not realizing that the language actively penalizes you for doing that. Right, well, I think I figured out how I want to do it at least. I'm gonna just implement it and you'll see if this makes sense. Yeah, you can see if you think this makes sense. Is it count? It should just be size, right? Size. Hmm. Do you need these points? Or do we just want... Hmm. It's actually very difficult to figure out a nice way to do this. See you, Fiber. The only thing I don't need is... No, wait, I do need that pause as well, don't I? Shit, this is obnoxious. Start and end. I see. That's annoying. It's just an annoying array min. Is all it is. Literally just an annoying array min. This is X mid. Well, we can get rid of this shit. At the very least. Well, we can do it off the points, can't we? Yeah, we can do it off the points. Okay, let's say that you do this, right? And then this becomes like points. What do you need? And then do we just do like plot args? Let's do like this. Hey, Major. I'm gonna be doing this all day tomorrow, too. We're gonna get this nice. It's worth spending some time to make this good. Are there guards for num M's? Got one, make sure I'm not missing anything. I think the guard will just tell you that you're wrong, if I recall. So the way Puffer works is like unless you're trying like normal usage of you messing things up, you should get like a API usage error, which means that you screwed up. And if you're hitting internal shit, it's like I screwed up. Jess, I'm trying to refactor this thing nicely, and it's actually very, very difficult to come up with a nice way to do plots. It's like this, yeah, it's just tricky. I don't know. Um, I think it'll just tell you, you'll probably get some API usage error, but it's not gonna, like, do it gracefully. So this point here is X-Men. Yeah, because it gets scaled, right? Shit gets scaled. So wait, if we just auto scale, what happens if we auto scale? I think that it's better to do like this, maybe? Yeah. And then we can do vertex buffer. Particles. I like this. Let's do glyph. Do glyph. Or vector 2. Float vertices. Oh, it's on particles. So let's just do it this way, right? It's like pretty similar, no? It's actually, yeah, not that far off. And then we don't need filter. This feels a lot better. This is already starting to feel better. This is going to be good code, damn it. Even if it's gonna take me however the hell long it takes. This is gonna be good code. This feels better already. Let's do shader, star, shader. And then we can do what notification did I just miss? Discord? I mean, this is like... Because see, now what I can do is... Going back and forth in this shit. Something like this will work, right? Now, the only problem with this... We would kind of like to have... Hmm. We would kind of like to have the pixel chords, right? So this is close. Oh, hang on. So this can just be two screen, right? So we can just do... Don't need shader. Right, and then this is basically this entire thing. It's something close to this, man. I kind of actually like this because... Yeah, this is gonna end up okay, no? This gives you particles. Spot. And then it would just be like void plot. Oh no, wait, we can just do, yeah, right from this. This doesn't even need it. Okay, this is fine. Yeah, this is fine. So you just do 2 picks. Right, so we did auto scale on this. And then we do plot GL. And then what we would do is we would just check collisions right here. Right? Jess, there's not an issue. It's just that the quality is shit. It's gonna be way nicer. It's just like having basic pride in my work. And wanting this to not just be a rotten mess. I think something like this is better though, right? Because now we get this into... So we just take our thing. Now, arguably, it's a little annoying that we have to go through this point format, but there's no way I see around that. I guess we could pass XYZ. What's points have? Yeah, but actually passing XYZ is not even that convenient, is it? Oh, we could very, very easily make like a 2 picks, like float or whatever that wraps this. Yeah, we're good. This is fine. So I think this is the right layer of abstraction. This is like lower level than you'd expect, right? Because this just gives you the screen chords back, and then it lets you do whatever with them. Which I like. Okay. What do we do from there? Well, I think what's going to happen is I'm going to, like, finish this tomorrow. But, like, let's say that I do this refactor, right? What is left that's gross here? Like, there's some refactor in plot args. It's not that hard. I might fiddle with the axes drawing a little bit. But it's not bad. I guess the main struct is a little iffy. But, like, the rest of this gets a lot better, right? And then we're going to end up with... It's like plot and plot GL. Yeah, we're just going to end up with, like, plot and plot GL. And then the UI will get fixed. We can definitely... Hang on. It's definitely going to take some work, but I think we should be able to get something pretty good tomorrow. I don't know if I'll finish it, but we'll get something like actually workable tomorrow if I don't slack off on this. Yeah. And for reference, folks, this is what we're building. Perf RL dashboard that looks pretty cool. Okay, I'll be back 10:30-ish a.m. Eastern tomorrow. If you want to support my work for free, GitHub, star it. Helps a lot. Feed the puffer star. If you want to get involved with development, this is all open source. Join Discord. We are advancing RL right here. And you can follow me on X for more RL content, including my latest research and my educational content. Thank you all, and have a nice evening. This tomorrow, Saturday, is going to be ridiculous perf optimization.